Shika, and today we're diving into something that's going to shape the future, AI. This can be seen in basic platforms like Alexa and Siri, but this is also seen in apps like Netflix and YouTube recommendations. And of course, we can't forget the infamous ChatGPT, which we've all used. But AI is so much more than that. Today we're going to dive into the AI basics, and this will give you a good understanding of what's upcoming. First, we're going to talk about the types of AI. There are two ways we can do this. And the first way, we're going to do it based off of capabilities. So, when we're trying to categorize AI based on capabilities, we can think of it as like a ladder, right? So the first step on the ladder is narrow AI. So think of this as the AI chatbots that we see or the AI assistants. They can only really do one thing. They're narrow, but they're really good at the thing they do. Next up on the step, we have AGI. This stands for Artificial General Intelligence. So hypothetically, because this is still hypothetical, this type of intelligence should mimic basic human emotions, thoughts, feelings, and basically be a human. That's why it's called general intelligence. The next step and final step on the ladder is super AI. So super AI is completely theoretical. At this point of our knowledge, it's science fiction. This AI is theoretically meant to be better at us than everything. Processing emotions, feelings. It's supposed to be human 2.0, for example. Now that we've finished discussing about how AI can be based on capabilities, we're going to categorize them based on how they function. So to understand how we can categorize AI based on functions, I'm going to draw a simple pyramid. The idea of this pyramid is to show that the functions kind of build on top of each other. One thing depends on the other. So the most basic type of AI are reactive machines. So reactive machines do what they sound like. They react to what they're given, to the input they're given. So think about a pre-programmed chess game, right? So when you're playing chess, the AI just reacts to what you're inputting, but it doesn't remember what you played before or what other players' common strategies are. The actions that it does are completely pre-programmed by the person who made the app. Next up, we have limited memory AI. So limited memory AI essentially remembers the past. So take self-driving cars as an example. It uses past driving data to help better navigate obstacles, detect navigation, and just make better decisions in general. Next up on the ladder, we have what's called theory of mind AI. So theory of mind AI is completely hypothetical, but what it's supposed to do is help us understand our emotions, beliefs, and intentions. It's kind of like the emotional intelligence for machines. The last and final thing on our ladder is what's called self-aware AI. Self-aware AI basically means that the AI is conscious of the fact that it's AI. And this kind of sounds like a weird thing, but a strong sign of what we consider intelligence is that they're aware of themselves. So self-aware AI is kind of like the epitome of artificial intelligence. Now, we're going to talk about how AI is built. So to do this, there are 6 key steps that we need to follow. First is identifying a problem that AI can solve. Next is collecting the data for this problem. Data in this day and age is extremely important. In fact, the person I interviewed even mentioned that data is king. Don't worry, you'll see the interview later on in the playlist. Next up is modeling using the data that we collected. Then we have to train the AI model. Then we have to evaluate how effective that AI was in solving our problem. And lastly, we have to deploy it in the situation where we need to use the AI and obviously track it and make edits when needed. Now, let's take a close look at each step individually. So first off, problem. What could that look like? It could be something like fraud. So maybe someone is stealing someone's credit card. How can we fix that or prevent situations like that in the future? This can also be optimization in businesses and production lines, stuff like that. This can also be seen in other fields, such as medicine. Drug development is a big problem, not a problem, but a thing that AI can be used to work towards. Then we also have data. So data can look like basic statistics, percentages, mean, median, mode, basic numbers. But it can also be more personalized and nuanced, like characteristics of someone. Maybe we're trying to figure out the best person for a specific job. So maybe we're trying to identify specific characteristics. That would all be valuable data. Next up, we have modeling. So the data that can be fed into the AI to model something. So this model is also called a neural network, because this is supposed to stimulate how a brain actually works, hence the name neural network. Then we have training. So we need to actually train this AI model to work the way we want it to. So we use machine learning algorithms to do this and feed it data that can help the AI form relationships from certain characteristics. For example, maybe you wanted to identify common characteristics of someone owning a house. So we want the AI to create relationships based on wide amounts of data. This training also involves fine-tuning, which is just making small little edits so that the AI works exactly the way we want it to. After training, we have evaluation. So once we've trained the AI into how we want it to be, we have to check if it's right. So people normally evaluate it based on accuracy and precision. So accuracy simply means how close it is to the right answer, while precision basically means how close the results are. For example, if the AI gives us results as 4.9, 4.99, 4.91, or 5.01, we would say that it's pretty precise. But maybe the answer was actually 10. So it's not really accurate, but it is precise. And we use this as well as other defined metrics to evaluate the AI model. Lastly, we have deployment, which is basically setting out the AI model into the real world. But this does not mean that we stop interacting with the AI. Even after deployment, we have to keep track of the AI and make edits yearly or as we see fit. Now, we're going to talk about why AI is advancing so fast. So there are 4 main reasons why this is happening. First, we have computing power. Now, more than ever, current chips, graphics are all super powerful. This enables AI to gather data and model this data much quicker than ever before. We also have more deep learning. Before, AI was only delegated to basic tasks, but with the advent and spread of deep learning, AI can now be used to stimulate advanced problems. Next up, we have meta learning. And meta learning is where AI makes other AI models, basically doing what a group of data scientists were able to do, which is kind of insane in my opinion. Next, we have accessibility. So with the advent of ChatGPT, Google AI, and other AI models, people are now even more curious and are use more AI, which enables them to discover and even create their own AI models. Now, we're going to talk about how AI is used. On this whiteboard, I have 3 things kind of listed, but there are a lot of areas where AI can be used, but this is just a few of them. So in business, AI can be used in helping customer service, SEO, marketing analysts, and AI chatbots. These all optimize business processes. Next up, we have healthcare. So this can be used in drug discovery by feeding in lots of past diagnoses, surgeries such as robotic surgeries, personalized treatment plans, which take a long time to make, but AI can really expedite that process, as well as analyzing x-rays and MRI scans. Lastly, we have transport. So as I mentioned before, self-driving cars, AI plays a huge role in that. Traffic light timing. Even though it gets annoying, AI is used heavily in that. Public transport schedules are also use AI, as well as figuring out when bridges or roads need to be repaired. Hi guys, that's it for today. I hope you learned a lot about how AI is used and the basics of AI. If you want to learn more, please check out my interview with Mr. Rajiv Jaswal. He has an extensive career in tech, holding high-level roles at Red Hat and Rapid7, but eventually became the CEO and founder of Gratitude, an AI consulting company. His experience gave a lot of insights about how AI can be used in real life. So if you're interested, please check it out. See you next time!